Hi, in this video, we're going to do the chi-square activity with a slight variation. And so first, let's look at the background for our activity. So the background story is that we have a new zookeeper who must deliver a trainload of animals to another zoo. And due to the zookeeper's lack of experience, they put the herbivores and the carnivores in the same railroad cars. And so, as you can imagine, this resulted in some scuffles between the animals on the way to the new zoo. And so we're looking to document those injuries, and specifically, we want to answer this particular question. So is the type of animal, herbivore or carnivore, related to the injury status? No damage or some damage? And in your activity, you are given an Excel file, and you use the data from this file to answer this question. And so the variation that we are going to use is that instead of using all of this data that is provided by our zookeeper, I'm going to generate my own data from just one railroad car. And so this box of animal crackers is going to represent my railroad car that has a mix of herbivores and carnivores. And so I'm going to look at each of my animals, and I'm going to document how this animal scores on each of my two variables. And so we should look at our two variables first of all, because this gives us some clues about why we're using chi-square. And so our two variables are the type of animal, herbivore versus carnivore, right? So type of animal, and it's categorical, right, or nominal. And so we're classifying animals as either carnivore or herbivore. And then we also have our second variable, which is the assessment of damage. So is the animal damaged or not? So again, a categorical or nominal level variable, because we're classifying the animal as either not damaged at all, like this tiger here, or damaged, like, let's see, oh, yes, this lion here. And so, full disclosure, I got this in my grocery pickup, and they did an excellent job in transporting it because none of my animals were damaged. So I had to damage them myself to make this activity work. And so I bit some legs off before we started here. And so I'm going to generate this data. So I have an elephant that is missing some legs. So we have a damaged herbivore. Then we have, this one is really tricky. I think this is a gorilla. I'm not sure. I'm gonna count it as a gorilla. And he is totally intact, not damaged at all. We have a perfectly fine camel. We have another not damaged herbivore. We have a, it actually looks like there's some natural damage here to our elephant's trunk. I'm going to count our elephant here as damaged. So some damage to his trunk. We've got another elephant that looks like he's maybe not so good as well. We've got a carnivore, a tiger here, who is not damaged. So as you can see, for each of my animals, I'm just documenting and giving each one a score in my data set here. I'm classifying them into each of these categories. So I have an elephant who is very clearly damaged. He has a bite mark out of him from a carnivore. And so I'm going to go through and categorize and score on each of my two variables here all of my animals in my railway car. For instance, I have a giraffe who is not damaged. So it seems like so far I have a lot more herbivores than I do carnivores. So not evenly distributed in my package here, but we'll see what happens when we get all the way through. Okay, so I went ahead and documented for all of my animals and recorded my data here. And so each one represents one animal from my railroad car based on these categories. And so what I want to do is to calculate a frequency table. And so remember that chi-square, because we're dealing with nominal level variables, we are dealing with frequency counts. And so I need to know how many animals are represented within each of these categories. And I also know that I'm doing a two-way chi-square because I have two variables instead of just one. So I have the type of animal, carnivore versus herbivore, and I have the status of the animal, damaged versus not. And so to fill in my table, I'm first going to look at, okay, the sum of all of my damaged carnivores. And so I had 4 damaged carnivores. Then I'm going to look at, well, how many non-damaged. So I'm going to get the sum of non-damaged, the sum of not damaged carnivores. And then I'm going to do the same for my herbivores. Damaged and not damaged. Okay, so these are my observed frequencies, and they were literally observed, right? I went through the box and counted and tallied up my counts and then summed them to get my observed frequencies. Then what I want to do is to calculate my expected frequencies based on my null hypothesis. And so one of the first steps with hypothesis testing is to state your research hypothesis and your null hypothesis. And we should base these on the background information, the question that was asked earlier. And so we said we want to know, is the type of animal related to injury status? And so my research hypothesis is going to be that there is a significant relationship between type of animal and injury status. My null hypothesis is that there is no significant relationship between type of animal and injury status. And so I want to calculate my expected frequencies based on my null hypothesis that assumes that there's no relationship between these two variables of type of animal and status of damage. And so my first step with calculating expected frequencies is to get my row and column and overall totals. And so first, to get my row totals, so I want to know overall how many carnivores do we have regardless of damage status. So we had 10 carnivores overall. How many herbivores did we have? I thought that I was getting more herbivores, but once I finished, I realized it's pretty balanced. And I had 11 herbivores overall, regardless of injury status. Then I want to look at my column totals. And so this is looking at how many damaged animals do I have overall, regardless of the type. So I had 10 damaged animals overall. And I had overall 11 undamaged. And so if I want to know my total sample size, how many animals did I get? How many cookies overall? There's a couple of different ways that we could do this, but we would just add all of these cells here together. And so we have 21 overall. So I'm going to put that in there. Just know that this is my overall sum, total number of animals. And then what I want to do is to calculate my expected frequencies based on these row and column totals that I generated. And so for each one, I'm going to do the row total by the column total divided by the total number of animals. So if I have my row total multiplied by my column total, I get 100, but remember that I want to take this and divide by my total sample size of 21. And so I'm going to do that for each of my cells here. And so here I have the same row total, in the same row. I have a different column total. And then I divide by my overall total. And you can probably already see that it's pretty close here with our expected frequencies are not too far off from our actual observed frequencies. So here, one more, I have my row total multiplied by my column total divided by the overall total. All right, so now I have my observed frequencies and my expected frequencies. And so what the chi-square test does is to compare the observed frequencies to the expected frequencies. So how much different are they? Right? Are my observed frequencies deviating substantially from my expected frequencies? And I expect that is not the case, but we're going to test just to make sure. And so what we're going to do is a chi-square test. And so I typed in equal chi to bring up all of these options. And so as you kind of click through, you can see different options. If I click on chi-square, CHISQ dot test, says that this returns a test for independence, the value from the chi-square distribution for the statistic and the appropriate degrees of freedom. So ultimately, right, that is what I want. And so when I click on that, it gives me the chi-square test, and then it's wanting me to give it some information. So it's asking, what is my actual range? What is my actual observed data? So I'm going to click on that, my observed frequencies, comma, and then to tell it my expected frequencies, I'm going to select that and close the parentheses and click enter. And so what this is actually giving me is my probability value, or my p-value. And so remember that in order for it to be significant, my p-value needs to be less than 0.05. And so this is 0.5. So this p-value is not significant. And so I know based on this, I need to retain my null hypothesis. But I want to report my actual chi-square test value, not just my p-value or my probability value. But once I have that p-value, then I can use that to get my actual chi-square test statistic value. And I do that by selecting this chi-square.inv.rt. So this returns the inverse of the right-tailed probability of the chi-squared distribution. So I'm going to click on that one. And then it's asking, okay, well, what is your probability? We calculated that. There it is. And it wants to know, what are my degrees of freedom? And so I have two variables. So each one has two response options. So if I take 2 minus 1 and then 2 minus 1, 1 times 1 is 1, so my degrees of freedom is equal to 1. I type that in, and this is my actual chi-square value, equal to 0.44. So I have a small chi-square value. I have a large probability value, and so I support the null hypothesis, or retain the null